Hello friends, Mark here from CNC Sourced. Today I want to give you the complete guide on CNC for 2023. Whether you're new to CNC or looking to expand your knowledge, this video will cover everything you need to know about this pivotal manufacturing technology. Stay tuned until the end for an exclusive insider tip that will revolutionize your CNC projects. First, what does CNC stand for? CNC is an acronym that stands for Computer Numerical Control. It's a manufacturing process that uses computer software to control machine tools like routers, mills, lathes, and more. These CNC machines can cut, carve, and engrave materials like metals, plastics, wood, and foam based on programmed instructions. So how does CNC machining work exactly? There are a few key steps. First, a 3D CAD model is designed on CAD software for the exact part geometry you want to create. This CAD file is imported into CAM, or Computer-Aided Manufacturing Software, which intelligently converts it into precise instructions the CNC machine can understand. This is called G-code. The G-code controls all the major parameters like the cutting speed, step-over percentage, tool paths, and more. After running simulations to catch any lurking errors, the optimized G-code file is sent to the CNC machine, which then runs completely automatically based on those dialed-in instructions. There are quite a few different types of CNC machines out there. Let's overview some of the most common ones. CNC mills use a rotating cutting tool to remove material and create a part. You've got 3-axis mills that move along the X, Y, and Z axes, as well as 5-axis ones with additional rotational capabilities for more complex contours. The 5-axis machines can tilt and pivot for greater flexibility. CNC lathes spin the material itself rather than the tool to cut symmetrical shaped parts like shafts, discs, or gears. CNC lathes are ideal for making precision round components. CNC routers cut softer materials like wood, foam, and plastic. They're lower cost than industrial mills and great for hobbyists wanting to take on custom woodworking projects. Their flexibility makes routers suitable for products like signage, furniture, and decorative pieces. Water jet cutters shoot an extremely high-powered, narrow stream of water mixed with abrasives to cleanly cut through granite, glass, metals, and more without heat damage. Use water jets to precisely slice materials too tough for lasers. EDM, or electrical discharge machining, slowly erodes material by creating controlled sparks between an electrode and the workpiece. It's perfect for machining hard stuff like tempered steel and carbide. In comparison to additive manufacturing like 3D printing, CNC machining is considered a subtractive process because it removes or cuts away from a solid block of material rather than building up layers. This makes CNC quite fast and suitable for batch production runs of parts made from durable materials. But 3D printing can create complex organic shapes without the need for dedicated tools. Each process has its strengths. An important distinction is between open-loop and closed-loop CNC systems. Open-loop systems just blindly run the programmed instructions without any feedback on tool position. Closed loops have sensors, so the machine can dynamically correct itself if any errors occur. Naturally, the more advanced closed-loop machines will be more precise and better at avoiding failures or damaging collisions. So why should you use CNC machining instead of manual approaches? In several ways, CNC delivers immense precision, speed, and capability advantages. Take precision. CNC machines can hit incredibly tight tolerances down to thousandths of an inch quite repeatably with no risk of human error. Automating the machining process also cranks out parts much faster than manual craftsmanship ever could. Plus, these machines work tirelessly 24 hours a day without breaks, fatigue, or lapses in focus. Transitioning between part designs becomes a breeze by simply changing the digital toolpath file loaded rather than needing to modify physical jigs or fixturing. Lastly, today's multi-axis CNC mills sport incredible movement flexibility. Intricate geometries with contour changes across multiple planes pose no issue with the dynamic software and hardware capabilities powering these machines. Alright, so what about starting up your very own CNC shop? Where should one begin? First, research and target specific customer segments and parts best matching local manufacturing demand. This informs intelligent machine purchases, catered towards projected jobs. Shop space is key too. Secure an appropriately sized facility with room to expand as needed once you start landing bigger contracts. Develop marketing assets like a nice website to enable secure online orders and collaboration. For the machining itself, you'll need efficient behind-the-scenes processes for tracking work, scheduling jobs, quality control, and shipping completed orders. It also pays to invest in reliable equipment rather than purchasing subpar machines to save on capital costs. Why? Flaky tools lead to repeated downtime and delays, sabotaging production, your reputation, and ultimately losing business. Instead, work towards smartly scaling capabilities over the first few years to qualify for more complex, higher-margin jobs. Becoming that local one-stop shop able to handle diverse machining requests is the goal. Okay, friends, that wraps up this complete guide on understanding CNC for 2023 and beyond. Hopefully, you now have much better grasp of the major CNC concepts, processes, and applications. Let me know if you have any other questions. I invite you to check out and search the CNC Sourced blog and community forums if you want to dive deeper into anything we discussed today. We have hundreds of detailed articles and discussions explaining all aspects of CNC and laser machines to take your knowledge to the next mastery level. Thanks for watching and keep making.